Math 1314, Tyler Junior College, Section 5.1, 2x2 systems, 2x2 linear systems of equations. It just dawned on me that this should say 2x2 systems of linear equations because the adjective linear is describing the equations. It only took me 7 videos to catch that. Yeah, well, I take pride in my grammar. Solving a 2x2 system by addition. In the previous video, which went on longer than I planned, we solved 2 different systems. One where the values behaved, and the other one where the values were not so well behaved. And when I say values, I mean both the coefficients, not the coefficients, but the solution. The solution to the second example were some pretty obnoxious fractions. But I don't think I adequately got the opportunity to demonstrate the approach to solving by addition. So I'd like to do one more example, and this one won't take too terribly long. We're going to solve this system. The first equation is 7x plus 2y is equal to 85. And the second equation is 5x plus 8y is equal to 133. I still have these steps, if necessary, rewrite so each equation is in the form ax plus by equals c. In other words, line up everything including the equal signs. If necessary, multiply one or both equations by well-chosen numbers. The word by should be in here. By well-chosen numbers to set up an opposite pair, and then add the equations together and solve and find the other value. If you're going to solve a system by addition, all of the work is up front. The rest of it is just following steps. Or rather, I should say, all the decision making is up front. You have to decide on the variable to eliminate and how to set that up. The choice of eliminating the x or the y is arbitrary. You can pick either because you can always set up an elimination regardless of the coefficients that currently exist. But sometimes it's easier to set up one elimination than another. For example, in this one, I'm going to set up the y's. And my motivation behind that is the coefficients of the y's are currently 2 and 8, and 2 is a factor of 8. Or vice versa, 8 is a multiple of 2. Regardless of how you look at it, that means I can turn the 2 into an 8 pretty easily. So I can just multiply the first equation to set up an opposite pair. What will I multiply the first equation by? Well, I would like for this to be a negative 8 to cancel the positive 8. To turn a positive 2 into a negative 8, I have to multiply everything by negative 4. So you don't always have to multiply both equations by a well-chosen number to set up an opposite pair. With a little observation, sometimes you can just multiply one equation by a well-chosen number. Multiplying the top equation in this system by negative 4 will give us negative 28x, negative 8y, and then 85 times negative 4 is going to be negative something. Looks like it's going to be negative 340. I'll double check that. I'm pretty sure it's right. The more I think about it, the more right I feel I am. But not to be arrogant, I would rather get it right than try to do it in my head. But I'm right. The bottom equation we're going to leave alone as 5x plus 8y equals 133. And we have our opposite pairs set up on the y's. They cancel. When we combine the x's, we get negative 28x plus 5x is negative 23x. When we combine the constant terms, negative 340 plus 133, first off is negative, and then the difference, which appears to be 307. Let me just add real quick. Yes, the difference is negative 307. Divide both sides by negative 3 to get x equals negative 207 divided by negative 23, which first off is positive, and secondly, I'm pretty sure it's 9. But just to make sure I didn't set up a train wreck, it is 9. So x is equal to 9. But now we have to figure out the y. Remember, once you know one value, you can substitute it into any original equation and calculate the other value let's use the original first equation of 7x plus 2y is equal to 85. The x is 9, so 7 times 9 plus 2y is equal to 85. 7 times 9 is 63. And now we're just 2 steps away. Subtract 63 from both sides. And we get 2y is equal to 22. Divide by 2 and we get y equals 11. Our solution is the ordered pair 9, 11. You could always check by substituting the values back into the original equations to verify that your ordered pair is indeed a solution to the system. But in this case, take my word for it, because when I built the system, that's the solution I had in mind.